What's up, guys? Welcome to Code Porn, sponsored by viewers like you through our Patreon page. Today we've got an awesome episode for you because we have Jeremy Clark on the show to explain lambdas and how they work. Jeremy, also known as Jeremy Bites, is a Microsoft C# MVP and Pluralsight author with many courses on topics from generics to design patterns. With over 15 years of experience covering all of the aspects of the development lifecycle, Jeremy knows a thing or two about code. Quite a few times, Jeremy has traveled the difficult road of learning new concepts, so you'll find him speaking all around the country, helping developers fast-track their learning by sharing his experience and breaking down complex topics into easy and understandable bites. So it's awesome to have him on the show today. Let's go ahead and jump right in. Hey Jeremy, how's it going?
Hey, pretty good, Dustin.
Yeah, thanks for coming on.
Yeah, glad to be here. I actually love talking about Lambda expressions because it's something that was really sucky for me to learn. And so anything that I can do to make it easier for other folks is something I love to do.
Yeah, lambdas is one of those things that actually even still today, a lot of developers they can't grasp the concept. But lambdas, if you go back to even before lambdas when we were just doing regular delegates, I mean, even still delegates was, and it still is, of course, such a hard concept to grasp because it's such an abstract way of thinking about things.
Yeah, delegates are fun. I actually did an entire video series on delegates just because, and that's another topic I love to talk about. In fact, I've got a session that I do called Get Funky, which is all about delegates and funk and action. So I always try to have a lot of fun with that kind of stuff.
Yeah, I mean, that's the only way that you can really approach this kind of topic because even though it's very simple, it's just that barrier to entry. It seems so high and so hard to get through. So just kind of making fun of it really does help break down that monotony of it. So we're going to talk about the anatomy of a lambda expression. So of course, you're going to go over what a lambda expression is, the different variations of it, and so on, right?
Yeah, definitely. The thing that really kind of gets people is the way that we're introduced to Lambda expressions. Usually we see them in someone else's code, so we might see LINQ, and I love LINQ. LINQ is friggin' awesome. And, we walk up to this Lambda expression and we see, okay, well, there's a where. That means that we're probably doing some kind of filtering. And I see this first name compare equal to something in a text box. Okay, that's going to return a true false value. But I look at this and I'm like, okay, what is this P and where does it come from? And why is this important? So I kind of have a general idea of what it's doing, but I don't really understand kind of fully what's going on. And, it's the same thing when we run into them with delegates. Again, func and action are really cool built-in delegate types. But, again, I look at this Lambda expression and I see, okay, well, it's uppercasing the last name property of something, but what is that something? Where does it come from? And, we also run into them with callbacks and event handlers too. Now, when we look at what a Lambda expression actually is, it's an anonymous function. Now, an anonymous function is just a function without a name, and we use this to create anonymous delegates. That's the primary way that we use lambdas. Now, if you don't know what an anonymous delegate is, that's okay, because once we get into the code, I'm going to show you an example of a name delegate, an anonymous delegate, and how we can turn that into a lambda expression.
So just in general, what is a delegate? How do you explain that to a developer who is failing to grasp that concept?
Well, a delegate is a type. So just like we have other types like integers or lists or custom types we create like person and orders, those are all types that we have. A delegate is a type, but instead of describing a class like most of our objects are, it describes a method signature. So what we're really looking at is something that takes a certain type of parameters and returns a certain type of value. So it's a type that describes a method signature. So when we assign delegates to it, we're actually assigning methods to it rather than other types of objects that we might have.
Yep, that about sums it up.
So when we're talking about lambda expressions, they're really designed to be very, very compact. And that's really cool because when I use them in LINQ statements, I want them to be very compact. But there's kind of a lot of syntactic sugar that gets added on top of them. So the way that I like to approach lambdas is to take a look at kind of what the basic parts are, and then let's break down that syntactic sugar a little bit differently. So there's just three parts to a lambda expression. There's the parameters, and that can be 0, 1, or more parameters. And then we have that cool equals greater than sign. And that's known as the goes to operator. It's also called the lambda operator. And then on the right-hand side, we either have an expression or a series of statements. When we're talking about an expression lambda, this is going to return some type of value. So in our example here, we see we have a variable that's called person and also of type person. And then we have the cool lambda operator in the middle. And then we're taking the first name property of our parameter and comparing it to the string John. And this is obviously going to return a true false value.
So this is basically a shorthand version of writing out public bool some method with person as a parameter and then returning the result of the evaluation of first name is equal to John.
Correct. So if we wanted to assign a method signature to this particular lambda expression, the method would be a method that takes one parameter of type person and returns a Boolean. So it returns a true false value. So that would be the signature that this lambda would match up to.
Are all expression lambdas predicates, meaning they're all returning true false?
Not true false. They could return other types of values as well. And that's one of the things that I like to, well, I don't want to say like, but LINQ is really awesome. Did I say that earlier? So there's a lot of delegates that are part of LINQ. And the most common ones we see, like with the where statement, those definitely return true false values. But when we get into things like ordering, now we're returning an object that implements the IComparable interface. So that's something that we can give some type of order to. So it's not always a true false. It could be that we're returning a property. It could be we're returning some other value. We could be returning integers. We can actually return whatever we want, just like we can return whatever we want from regular methods.
So are lambda expressions, are they only used with LINQ queries or can you use them outside of LINQ, just wherever?
I use them in a lot of places. And the simple example that I'll show you today, I'll be using it as an event handler, which is actually kind of what this other example is. Now, when we're talking about lambda expressions, they were created for LINQ. This goes back to C# 3.0, which was .NET 3.5. And that's when we got a whole bunch of these really cool new C# language features. Every single one of those features was to support LINQ. Now, one of those was lambda expressions. Another one that we got was the var keyword so that we could do anonymous types. And extension methods, which are incredibly awesome and cool. So these things were all put into the language to support LINQ. Now, we do use these features outside of LINQ, but that's what they were created for.
All right. So what we've got here, a statement lambda, and this is essentially a void function or a void method.
Right. So again, an expression lambda will return some type of value. A statement lambda does not return a value. It just performs some type of work. So if we look at the signature for this one, this might be something that we would hook up to an event handler of some kind, right? So most of our event handlers have two parameters, an object sender, and then some kind of event args. And so if we have a signature like that, then we can perform some kind of work. So again, in this particular example, we're populating a list box and we're also outputting something to the console. But we have the same basic layout. So we have the parameters wrapped in parentheses, then we have the goes to operator, and then we have our series of statements. And in this case, they're wrapped in curly braces since we have more than one.
Now, this isn't a method, or this isn't something you would write like you would a method. This is a piece of code that you would write inside of a method, maybe even assigning this to a variable that you could use multiple times. Is that right?
Yes. So this is an anonymous method. Let's see. Technically, the word would be anonymous function, which is a function without a name, but they don't just stand on their own, because if it stood on its own, we'd have no way to actually reference it. So usually where we use these are where we're inlining our code. So in this case, this particular statement lambda wouldn't stand on its own. It would probably be on the right-hand side of an equals operator that we're assigning to a particular event handler.
And what would you say the major benefit of this would be? The one that I could think right off the top of my head is when something is expecting a delegate, specifically an event handler. Instead of setting that delegate up, you can just pass in this anonymous lambda expression.
Yes, so that's one of the things that I really like about it, because there's advantages to having that separate named method. And for example, if I need to reuse a method multiple times, then it makes sense for me to have a named method. But if I'm only using this code in this one spot, I really like having it in line, because now I see the code next to where I want to use it. So I don't have to go look somewhere else for the functionality. I see it right there in line. And there's some other more subtle features, which I won't get into today. A really cool feature is what's known as a captured variable. So other languages refer to these as closures. And what this allows us to do is it allows us to basically grab a reference to a variable. And even though that variable would normally go out of scope by the time our Lambda expression actually runs, we can still maintain a reference to that and use that variable. So that's a really cool feature. And I actually show that in one of my other videos. I'm actually working on a series right now, which is about lambdas and LINQ. And in the first part of that series, I actually show how captured variables work. And again, it's kind of a cool thing and a little difficult to wrap your head around that first time.
Yeah, closures are definitely a very hard concept to grasp. But once you get the grasp of it, they're really awesome. But until you get to that point, they can lead to a lot of trouble, unfortunately.
Right. So, that's why I start with the basics like we have here. So the lambdas that we're showing right now, this expression lambda and the statement lambda, these are in a very verbose state. Because again, when we're talking about lambdas, there's kind of a lot of syntactic sugar that we can use to make these very, very compact. Now, to help make things compact, there's a convention that people often follow, and that's to just use a single letter for parameter names. So this isn't something that's required. We can actually name our parameters whatever we want. But because we're kind of squishing things down as small as possible, it's pretty common to just use a single letter for the parameter names, especially when we're using them in LINQ methods. So what I do to make sure my brain keeps track of things is I'll try to use a letter that reminds me of what the type is. So for example, in this expression lambda, I would use P, and hopefully my brain would remember, oh, I'm dealing with person types here. So that will help me remember exactly what that refers to.
That's a good idea. I always use C. I don't know why, just the letter C.
Just
And then
always?
just always. I have no idea why. Maybe that's because that's the examples that I learned on. But it's always C unless I have chained expressions where C won't be available.
Oh, yeah.
Then I'll use D. But I don't know why. I just always use C.
Okay, well, that's a classic example of developers being really bad at naming their objects.
Yep.
so,
Exactly.
so you're in good company. So once we kind of start shortening these things, again, single letter parameter names aren't required, but they're pretty conventional. Then we get into the things that are really confusing. The first thing here, this is a term that will make you sound really smart. So parameter type inference. Try to use that in conversation with other developers because they'll think you're a genius. But what this means is that if the compiler can figure out what the types are for our parameters, we don't actually have to type them in. And we have to remember the way that we're using lambdas as delegates means that we're trying to conform to a particular method's signature. So that means whatever we're assigning this to, the compiler already knows what we're allowed to assign to it. So that means that we don't actually have to be explicit with that. So when we look at this example, we see S and E, and this might be the same object sender and event args E that we saw in our previous statement example. But because the compiler can figure that out, we don't actually have to put the types in. Now, these are still strongly typed, so this isn't some kind of weird dynamic thing going on. It's just a shortcut because the compiler already knows. And again, what this allows us to do is make our syntax much more compact.
Now, it's good to point out that even though we haven't specified the parameter types, you'll still get the strong typing through IntelliSense inside of the expression body.
Yes, definitely. And I'll show you that once we start looking at some code. So another thing that's interesting is that if we only have a single parameter, we don't have to put parentheses around it. So in this case, we just have E floating by itself. So we just have one parameter that's needed for this particular lambda. And because the compiler can figure out the type, we don't have to put the type. And because there's just the one parameter, we don't have to put parentheses around it. And this is really common in the world of LINQ because a lot of the LINQ methods actually take delegates with one parameter. So this will be very common to see parameters like this when we're using LINQ methods.
Yeah, it's fairly uncommon to see the LINQ methods actually taking in multi-parameter delegates. So it's more common to see that single parameter without the parentheses in there.
Right. And there's some interesting methods like join that they'll actually take multiple delegates as parameters, but each of those delegates just has one parameter itself. Mm-hmm. So that's pretty common. Now, to make things even more compact, if we only have a single statement, we don't need curly braces around it. And so, as we can imagine, if we combine all of these elements with the single letter parameter names, the parameter type inference where we don't have to put in the types, optional parentheses for single parameters, and optional braces for single statements, we can see that we can come up with a very, very compact syntax. But again, it's very difficult to walk up to that first time because we're not quite sure what's going on here. And there is one other variation that we don't really run into this when we're dealing with LINQ methods, but I have come across this when dealing with different types of frameworks that need delegates. And there are times where we have delegates that don't take any parameters at all. We can still use lambda expressions in those situations. All we do is put a set of empty parentheses where our parameters normally go, and that would just specify that this delegate doesn't take any parameters at all. So, are you ready to jump into some code?
Yeah, let's jump in and put this stuff to use.
Yeah, so what I'm going to do is we're just going to start out by doing something. This is about as simple as we can get. Do you want to see my awesome application? Are you ready?
Let's do it.
Here it comes. Cool, it came up on my other monitor.
Nice.
Cool, it's a screen that has one button that says click me. And when we click the button, nothing actually happens at this point because we don't have any event handlers hooked up. So what we're going to do here is we're just going to hook up an event handler the way we normally would. So this is called click me button. So I'm going to say click me button.click, and then I'm going to say plus equals. And I'm a lazy developer, so I'm going to let Visual Studio do all the hard work for me. So it says, hey, do you want to create an event handler? Press tab. Okay. Do you want to call it this? Press tab again. Okay. So this just created the event handler that I need. Now, the thing about event handlers is they are just delegates. Now, events are a special kind of delegate, but they follow the same rules as other delegates. So the method that I'm allowed to assign to this click event handler has to have two parameters, an object and a routed event args, and it needs to return void. So the method signature is specified by the click event itself, and that's why Visual Studio can create this method for me. And in the same way, we can use this same feature that the compiler can figure it out so that we can build our Lambda expressions with that very compact syntax. So let's just go ahead and do something really simple. We'll just do a message box.show, and we'll say hello world, because that's what we're supposed to do when we're learning something new, right? And as you can imagine, any bets on what's going to happen when I click the button?
It's going to crash.
Oh,
it works.
You have absolutely no faith in my abilities.
Well, every time I do that, it crashes. I don't know.
Yeah, I actually have another demo I do where when you click a button, it throws an exception on purpose. That's really awesome to have. So what we have here, again, event handlers are just special kinds of delegates, is what we would call a named delegate. And that just happens to be a delegate with a name. And in this case, the name is clickMeButton_click. Now, we talked about how Lambda expressions can be used for anonymous delegates. So that means we have to figure out what an anonymous delegate is. Well, if we go to the documentation, we find out that the official definition for an anonymous delegate is a delegate without a name. Don't you love those kinds of definitions?
That's awesome.
I love them. But basically, all we do to create an anonymous delegate is inline the code. So what I'm going to do is I'm going to highlight the parameters and the method body of our name delegate. And then I'll just do Control C to copy this. And then up here, instead of assigning to our named delegate, what I'm going to do is I'm going to use the delegate keyword, and then I'm going to paste. So what we've just done is we've inlined this code. And at the same time, we've created an anonymous delegate. So this is a method that doesn't have a name that we've just put in the spot where we want to use it. And just to show that we're not actually using this name delegate anymore, I'm just going to delete it. Okay, any bets on what's going to happen when I run the application now?
Same thing.
Same thing? You think it's going to work? It works. That's brilliant. So again, going from a name delegate to an anonymous delegate, not that big of a deal. We basically just inline the code. Now, I talked about how a Lambda expression can be used as an anonymous delegate, right?
Right.
Well, we have an anonymous delegate. That means we can turn this into a Lambda expression. Okay, this is the most complicated thing I'm going to show you today. Are you ready for this?
Maybe.
Are you sure?
Let's do it.
Okay, so I'm going to delete the delegate keyword. And then in between the parameters and the method body, I'm going to add the goes to operator.
Nice.
Do you want to see that again? So I'm going to delete the delegate keyword and then add the goes to operator between the parameters and the method body. That's all it is. The first time I saw this, it was such like a huge flash of brilliance went through my brain. I'm like, wait, that's what a Lambda expression is? That's all it is? I can totally understand that. And obviously, if we run our application and click our button, we get the same results. So we haven't changed the behavior at all. But now what we have is something that we can add that syntactic sugar to. I talked about using single letter parameter names. Let's go ahead and just do that. So we'll change this to S, and we've already got an E. Now, since we're not actually using these parameters in our method body, not much else has changed. Now what we can do is we can look at some of the more interesting things. So I talked about that parameter type inference. If the compiler can figure out what the types are for the parameters, we don't have to put them in, which means I can delete this object and I can delete this routed event args. And this is what we walk up to, and it's a little confusing because we just see these letters hanging out in these parentheses and say, well, what are these? Well, these are still strongly typed. So if I hover over S, we see it is still of type object, which isn't that interesting. But if we hover over the E, we see that it is still routed event args. Now, the reason the compiler can figure this out is because it knows what we're allowed to hook up to this click event. So when we look at this, we see it's a routed event handler. And based on that, we know that we need to have an object S and a routed event args E as parameters for anything that we assign to this. And in fact, if we come here and try to add a third parameter, for example, now it's really, really hard to see, but there is a red squiggly under the opening parentheses of our parameters. Now, if I build at this point, we'll get a much easier to read error message. And it actually says that, you know what? The delegate routed event handler does not take 3 arguments. So the compiler knows what we're allowed to assign to this particular click event handler. So that's why we can get away without putting in these particular types. And again, these are strongly typed. So if I say E dot, we do get all of the things that we expect to find in a routed event args. So we see we have handled, we see original source, we see routed event, and we see source. And then the other 4 methods just happen to be the 4 methods that we get on object. So everything is still strongly typed. It's just the compiler knows about it, so I don't have to try to figure it out. Now you might say, this is just being lazy to a certain extent. You know, sometimes I say, yeah, maybe it's being a little lazy, but I've actually run into a situation where I took advantage of this feature. So I was working with this library, and it had a signature for an event handler that I totally did not understand because the event args for this particular event handler had nested generics in it.
Hmm.
Now, there's nothing worse than seeing nested generics because then you're like, okay, so what kind of method do I have to create to hook up to this thing? And seriously, I couldn't figure it out. And so what I did was I said, okay, well, you know what? I'm going to hook up a Lambda expression and then I'm going to hover my mouse over the event args and it showed me exactly what the type is. Because
Nice.
again, that's the only thing you're allowed to hook up there. So we can see that our Lambda expression is already getting more compact. Now, since I just have a single statement, that means I can get rid of the curly braces. And we can also get rid of some of this white space. So what we've seen is we've been able to take this, when we started, this was a completely separate method. And we've managed to compress it into just one very short line of code that tells us exactly what's going on. Now, the thing that I like about this, again, is it puts the code that we're actually running near the place where I want to use it. So in this case, I can see what happens when I click my button. Well, when I click the button, I get a message box that shows hello world. And I know you don't believe me, so we'll run it again. And we see we do actually get that message box that says hello world. So our behavior in this case is exactly the same as if we had the named delegate, but we've managed to create this very compact syntax.
Yeah, this is really nice. It might seem like an arbitrary example if you're watching this, but it's really important as you go on to do, the LINQ queries and you're dealing with some pretty crazy code, like you had mentioned, the nested delegates. I've also run into that issue. And yeah, when it comes to these anonymous Lambda expressions, they really do help out in a big way.
Right. And again, probably for this particular instance, I wouldn't do an event handler this way. But again, it's really good to start out simple so that we can understand the concepts. Because once we start diving into those more interesting things, a lot of different things happen. I didn't plan this, but I can show you a little more of a complex scenario. This actually would probably be kind of good to show. And this is actually something that comes from when I'm talking about delegates. This is the example that I show. And one thing that I have in here, which is really cool, is I'm assigning to a bunch of different delegates. Actually, let me show you this. Let me just walk you through this. So what I have here is I have a list of people on the left-hand side, and then I have these radio buttons to deal with string handling. Now, the idea behind this is that I want to pick how I output my data at runtime based on these radio buttons. So if I choose default, then what I'll get is the default toString, which is just first name space last name. But I have these other methods in place. So this one actually outputs the last name to uppercase. This one does the first name to lowercase. And then this one does last name, comma, first name. Now, the way that I'm doing this is with a delegate. I won't go into all of the details of this, but I'll just kind of show you what I have. So this method here, this assign delegate, is where we're hooking this up based on the radio buttons. So right now I have some static methods that are hooked up to do these various functions. So if I look at this first one, default just calls the default toString method, then last name to upper, uppercase the last name property, first name to lower, lowercase is the first name property, and then the full name does a string.format to get last name, comma, first name. Now, in the situation that we have here, I have to go to this other class in order to see these methods and exactly what they're doing. Now, hopefully the way that these are named helps me out a bit. But what I can do is actually take these, go through the same process of turning them into anonymous delegates and then turning them into Lambda expressions. So what I've just done, without showing you the details, is I've just switched those name delegates to Lambda expressions. Now, if we look at this, I have all of the code that I need all in one spot. So rather than going to a separate method for this guy right here, I can see that I have a variable called P, which happens to be a person object. And then I can see exactly the code that's happening. So I take the last name property and I do two upper on that, which uppercases it. And then I can see the code for the first name to lower. And then more importantly, for this one that just said full name before, well, how do I know what full name is? Well, here now the code is in line. So I actually have the string dot format and I can see it's doing a last name comma first name. So by inlining this code, it actually makes it so I don't have to go somewhere else to find out what this code is doing. Now, obviously, there's places we want to do this and places we don't want to do this. It works really well for really short kind of one-liner methods like we have here. If things get too long, then they do get kind of difficult to read. But I found that having the actual code that's running in a place where I can see it makes it a lot easier for me to follow and understand. Now, obviously, you do have to be comfortable with Lambda expressions with this, but that's why I encourage people to get comfortable with Lambda expressions.
So this is one of the things that I really like about Lambda expressions. So what is the definition of format person, and how are you consuming that?
So this is something that I go into detail actually in my generics videos. So you can see, actually, I'll walk through this entire sample in my C# generics series. But if we go to the top of the screen, what we'll see is that format person is a func of person string. And func is just a built-in delegate type. And when we learn to read func and action, which is another built-in delegate type, what this tells me is that this is a delegate that needs to take a person as a parameter and it returns a string. So that's what func of person string tells me. The last generic type is always the return type, and then we have parameters before that. So in this case, we just have one parameter. And so that's why when I can come down to these particular Lambda expressions, I have one parameter, and it is of type person. And then we can see that all of these return a string of some kind, either two uppering or two lowering or doing a string dot format. So all of these have the same method signature. They take a person as a parameter and return a string.
Now, without getting into, we don't want to get into generics here, so I'll add the link for the generics video in the description, and you can also click on this annotation here. So essentially, format person is a fancier way of writing out a delegate declaration. And what you're doing is assigning an executable method body to that variable, which will then be consumed later on and
That's
actually
correct.
invoked as a method. And there's a few design patterns that actually rely on this kind of thing, and it's very handy.
Right. And let me show you why I'd want to do this. Now, in this particular case, what I've done is I've created a person class, and this is a very simple class. So we can see it just has four public properties: first name, last name, start date, and rating. I have a default toString, which is first name space last name. But then this second toString method, this is where things get interesting because this is where I start using the delegates. So what this is saying is, you know what? This person class, its primary purpose isn't to decide what kind of output format it has. So what I'm going to do is I'm going to let somebody else just pass in a method that tells me how to format this output. And that's exactly what we're doing. So again, this takes a delegate, and our delegate is a func of person string, which means it takes a person as a parameter and returns a string. And so then what we do inside the body of the method is we just invoke that delegate. And invoking the delegate just means we're going to run it. And it turns out that delegates have this other cool property, which is multicasting, which means that we can actually have multiple methods assigned to a single delegate. So things get really interesting kind of the deeper we dive into this.
Yeah, so another way of looking at this is the toString method here is actually delegating the responsibility of determining the format of the return value of this toString method to something else. And that
That's correct.
something else is what we pass into this method, which is the lambda expressions that we assign based on the option parameter. So,
Right. What we're actually doing is we're following two of the solid principles by doing this. We're following the single responsibility principle because what we're saying is, well, the primary purpose of the person class is not to output its string format. So we're going to have someone else be responsible for that. And then we're also following the open closed principle. And what that means is that our class is open for extension, but closed for modification. And what we've done by putting this delegate in here is we've created an extension point for this class. And what that means is that I can pass in whatever delegate I want as long as it conforms to this method signature. And I'm basically changing the behavior of this class without having to change the class itself. And that's why it's really compelling in this type of scenario.
right. Although this can get fairly tricky because you have to trust that the delegate that's being passed in doesn't do something that it's not supposed to do.
Yes, and that's true of pretty much everything that we talk about, right? So I kind of run into this issue a lot because I like to show cool features like dynamically loading assemblies off of file systems and using interfaces to dynamically run things that we don't know about at compile time. And of course, I always get questions about, well, someone could do something pretty malicious in there. And it's like, well, not really, because basically what this func is, it's just a method that takes a person as a parameter, returns a string. That's really all that that method has access to. It doesn't have access to any of the other members of the of our classes or other parts of the system. So even though it kind of looks like a whole, it's really not.
All right, this is a really good example of using lambda expressions or anonymous functions in this way. And I really like the way that you start out explaining how to convert a named method into a delegate by just copying the parameter list and the method body and leaving out the name and the accessibility and then just moving that. That's a really good visual.
Yes, because it's really hard to make that leap between the named delegate and the anonymous delegate. Because we use named delegates all the time, even if we're not thinking about them in that way. And again, that's another reason why I like to show an event handler, because you know what? That's basic coding. Everyone knows how to hook up an event handler. They may not realize that they're actually using a delegate in that case, but they are. And so let's approach it in a way that looks very, very familiar.
All right. So you have a YouTube channel. It's Jeremy Bytes. Is that correct?
Yes, BYTES.
All right. And you can click this annotation and I'll add the link in the description. And so you have a series of videos on explaining generics, more with lambda expressions and LINQ. And then you also have quite a few Pluralsight courses as well on those topics, right?
Yes. So actually I don't have overlap between my YouTube topics and my Pluralsight topics. So I do have 7 courses on Pluralsight right now, which are things I love to talk about, like interfaces and dependency injection and design patterns. And there are certain situations where Pluralsight actually already has very good courses on topics that I like to talk about. So rather than not talking about them, I've decided to put those on my YouTube channel. So I do have a series on generics out there right now. I also have a series on delegates, and I'm working on a series on lambdas and LINQ right now. The first episode's currently published, and hopefully there'll be more soon. And then I have a couple other videos out there. There's one on extension methods. And again, that's another one of the cool features we got with C# 3.0 and is really key to understanding LINQ. So, I seem to revolve around LINQ quite a bit, which is not a surprise because it's really, really awesome.
LINQ is awesome. I mean, it's the best thing to happen to a language since anything, really.
Yeah, and it's really a functional style programming that we're bringing into our OO world. And, I think there's places for both styles of programming. And, I've really, really enjoyed it quite a bit. There's another thing that I really love to show in LINQ, which is how to move from an imperative mode to a declarative mode, where declarative programming is we tell the computer how to do what we want it to do. Whereas with declarative programming, we just say, I would like this to be done. Please go figure it out. So it's definitely a different way of approaching things, but it's really, really cool.
Definitely. Okay, so you can watch Jeremy's videos on his YouTube channel for free. If you don't have a Pluralsight subscription, send me an email and I'll add my email into the description. And I will give you a subscription card so you can watch Jeremy's videos for free and learn all about the goodness that is delegates and iFunky and all that other stuff that's very complicated.
But I make it easy.
You do make it easy. I've seen your Get Funky session, and what was the other one? The dependency injection, I believe. Those are really good. You take a good path on breaking it down and making it simple and easy to understand, digestible bits.
Yeah, and these are all things that were hard for me to wrap my head around. I spent a good 6 months on Lambda Expressions before the light bulb finally went on. And so what I try to do is make it so other people can take the shortcut. They don't have to go through that same effort that I went to. So pretty much all of the things I talk about are things that have been really important in my development career that were also kind of difficult for me to grasp that first time. So I try to make it easy to approach.
Definitely. So if you're in the Southern California area, be sure to check out the SoCal Code Camps, where Jeremy always has at least 10 sessions going on, it seems like.
Hey, I only had 6 at the last one.
All right, Jeremy, I appreciate you coming on and breaking this down for us. It's a pleasure having you.
Yeah, thanks. I had a great time, Justin.
All right, big thanks again to Jeremy for taking the time to go over lambdas with us. You can check out Jeremy's YouTube channel for more of his content. Follow him on Twitter and visit his blog at jeremybytes.com. And again, if you don't have a Pluralsight subscription and you would like to watch Jeremy's courses for free, email me and let me know, and I'll send you a subscription card. Now keep in mind the supplies are limited. All right, that's it for this episode. Be sure to subscribe to our channel, and if you like this episode, click that like button or visit our Patreon page and show your support. Thanks for watching.